All right, and we're in the run-up to a very, very crucial mission. You see the countdown clock over there, and this is going to be very, very significant because India's aiming for another milestone in space exploration. In moments from now, ISRO is all set to launch its space docking mission, or SpaDeX as it's being called. The PSLV-C60 rocket will carry two small spacecraft, each weighing approximately 220 kilograms into a 470 kilometer circular orbit. The mission seeks to achieve the rare feat of docking or merging together of these two satellites in space. Let's cut across live to Sriharikota.
Minus 25 seconds. Minus 20 seconds. Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Liftoff normal.
That's a marvelous liftoff of PSLV-C60 SpaDeX Mission on the go.
Plus 15
Sleek
seconds.
PSLV core-alone vehicle saluted against the night sky. A beautiful sight to behold.
जी हाँ, अभी आपने देखा सफलतापूर्ण उत्थापन PSLV C60 रॉकेट का रात को रोशन करता हुआ PSLV C60 अपने उद्दिष्ट कक्षा की ओर सभी तंत्र सामान्य निष्पादन करते हुए रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की है। प्रथम चरण का निष्पादन पूरी तरह सामान्य है। प्रथम चरण का कुल कार्यकाल लगभग 111 सेकंड का होगा।
Plus 1 minute.
Sharp 1 minute tracking.
S139 motor currently thrusting, developing 4,800 kilonewtons thrust. Its 138 ton solid propellants take 111 seconds to deplete.
Stage performance normal.
आसमान पूरी तरह साफ, इसलिए दूर तक हम देख सकते हैं। इस बार प्रथम चरण का प्रतिकन भी पूरी तरह साफ दिखाई देगा हमें।
Shar station currently tracking the rocket.
First stage separated. Second stage engine started. Closed loop guidance initiated.
प्रथम चरण के कार्यकाल के पश्चात उसे सफलतापूर्वक पृथक कर दिया गया है यान से तथा द्वितीय चरण PS2 स्टेज का प्रज्वलन शुरू हो चुका है।
The second stage has commenced its operation after the first stage separation. This stage burns on hypergolic earth-storable propellant combination of hydride of unsymmetrical dimethyl hydrazine and dinitrogen tetroxide. The legendary Vikas engine developing 800 kilonewtons thrust in vacuum.
यान के सभी तंत्र सामान्य प्रदर्शन कर रहे हैं और यान उद्दिष्ट कक्षा की ओर बढ़ रहा है। यह द्वितीय चरण है जिसका कार्यकाल लगभग 150 सेकंड का होगा। इस दौरान वह 800 किलोन्यूटन का प्रणोद उत्पन्न कर रहा है और इंजन जिम्बल की मदद से दिशा निर्धारण किया जा रहा है। इस दौरान यान क्लोज लूप गाइडेंस के अंतर्गत काम कर रहा है। कुछ ही क्षणों में हम पेलोड फेयरिंग यानी ऊष्मा कवच का प्रतिकन देखेंगे।
Payload fairing separated.
That's the next major flight event achieved, the separation of payload fairing.
Second stage performance normal.
प्रमोचन यान अब घने वातावरण से बाहर जा चुका है। अब इसकी ऊंचाई लगभग 130 किलोमीटर हो चुकी है, इसलिए ऊष्मा कवच की अब कोई आवश्यकता नहीं है। इसे यान से पृथक कर दिया गया है।
The second stage operation lasts for 151 seconds and will be jettisoned 4 minutes 20 seconds into flight. Shar and Port Blair stations tracking currently.
द्वितीय चरण तरल
4
पर
minutes.
आधारित चरण है। इसमें लगभग 42 टन तरल नोदक का प्रयोग किया जाता है। अब इस गतिविधि में अगली घटना होगी द्वितीय चरण का पृथक्कन तथा तृतीय चरण का प्रज्वलन शुरू।
Second stage separated, third stage ignited.
We are 4.5 minutes into flight and the third stage has commenced
Third
its
stage
operation.
performance normal.
द्वितीय चरण को कार्यकाल के पश्चात सफलतापूर्वक पृथक कर दिया गया है तथा तृतीय चरण ठोस नोदक पर आधारित तृतीय चरण इसका प्रज्वलन शुरू हो चुका है। पूरे तंत्र पूरी तरह सामान्य कार्य करते हुए
Third stage of PSLV operates
Plus
on
5
7.6 tons of HTPB based solid propellant. Vacuum thrust close to 240 kilonewtons and close to 2 minutes burn time.
PSLV का यह तृतीय चरण HPS 3 चरण के नाम से जाना जाता है, हाई परफॉर्मेंस PS 3 स्टेज। इसमें कुल 7.6 टन का ठोस नोदक और इस दौरान यह 240 किलो न्यूटन का प्रणोद उत्पन्न कर रहा है।
Third stage performance normal.
तृतीय चरण को सतीश धवन अंतरिक्ष केंद्र द्वारा निर्मित किया जाता है।
All right, and those are the informations that are coming in as far as the third stage being normal. Varshini, this is very, very significant information because the initial part of its journey at least, and it has been successful so far. How long is the entire mission going to take for the two spacecraft, which will be the Chaser? How soon will it be able to reach within the proximity and the docking to take place? How long is that part of this mission going to take?
What we're going to do is that we have two satellites. One is
Well, absolutely, yes, Madhav. It is a very overwhelming feeling right now standing here at Sriharikota and witnessing this very important launch of the PSLV-C60 SpaDeX Mission. And right now, we are seeing that the stage 3 is successful. And for the entire mission to get completed, it's going to take us 5,745 seconds, which is almost 95 minutes, which could take another 1.5 plus hours for the complete mission to get completed. And with that, we are given to understand that initial stages will take the two smaller satellites, the Chaser and the Target, to the desired orbit into the space. And later on, it is going to be the POEM-4 which is going to get launched into the orbit. And as we know, the POEM-4 has almost 22 payloads, which is also a very historic feat because we are launching 22 payloads at once into the space, and this will be getting completed at 1 hour and 35 minutes, like we understand at this point of time. So for the entire mission, we're going to wait for some more time for the scientists here to tell us whether it was completely
all right, we'll wait for you for that update there, Varshini. You're, of course, at Sriharikota. We'll be, of course, joining you in just a few moments. But let me quickly open this up and take it across to our experts who are with us, who can explain this for our viewers. Dr. Amitabh Ghosh is member of the NASA Mars rover mission. We also have with us Devapadatta Mishra, who's a former senior scientist at ISRO and CEO, Aerospace and Aviation Sector Skill Council of the NSDC of the Government of India. Mahesh Murthy is founder of Exceed Space, joining us. Thank you so much, gentlemen, for joining us this evening. Dr. Amitabh Ghosh, even as the launch third phase has been successful, in just a few seconds from now, we expect for those satellites to be reaching their orbit, which is about 470 kilometers from the Earth's surface. Take us through why this is such an important mission and what its applications will be for India's future ambitious space programs.
So if you think about it, so NASA has this International Space Station. So you need to have two spacecrafts aligned with each other, and that is called docking. And then, the power has to flow from one to the other. There should be a robotic arm where you can align the spacecraft. So remember, these are all at very high velocity. So there's a wide range of applications for docking. One is if you are familiar with the SpaceX roadmap to going to Mars with their spaceship, it requires refueling in orbit. So for that, again, you need docking. Refueling, for fighter jets, you have seen probably on Earth, right? So two jets align to each other and the fuel is transferred. So in the International Space Station, you have electricity that is the power systems have to align. Then if you see the Dragon spacecraft recently, you will see that docking is no longer manual. So you could have somebody, like if you saw the movie Apollo 13, you will see that they're manually trying to align. But here, there is no manual alignment. There is probably going to be robotic alignment. And of course, you have a backup manual. Then there's a big India's plan of bringing back samples from the moon. So rock samples from the moon. So you land on the moon, you go find with your rover the rock samples that you want. Then you have something called the ascent vehicle. So it's a small rocket which will go up. And then again, that ascent vehicle might have to dock with something. And then that will be captured and brought back to Earth. So this is one of the fundamental technologies you have many applications for. So I think it's a very relevant experiment. Basically, we have Gaganyaan, right? The Gaganyaan coming on board, and then India has its own plans of doing their own space station. Then you have Chandrayaan 4 presumably is going to bring back samples. So this is a technology which is going to prove and make all that happen.
Right. Right. Very, very significant over there. Thanks for breaking that down, Dr. Amitabh Ghosh. But let me bring in Mr. Devdatta Mishra. Mr. Devdatta Mishra, we have a space station plan. We have future Chandrayaan missions plan, and we have, of course, Gaganyaan, where, in fact, we will have our own, astronauts who will be going into space. In terms of this particular docking, as in fact, it has been explained by Dr. Amitabh Ghosh, it's going to be completely automatic. There's going to be no manual aspect of it. Can you take us through how exactly it's all going to work?
Yeah, hi. Thank you very much. I think this is a befitting event to end 2024 and to start new year 2025 with a great bang. Being an ex-ISRO, and I was involved with this Gaganyaan project. In fact, we are the people who started this human space flight program years back in 2018, after our Honorable Prime Minister Modi ji, when he declared from our Red Fort that we will send our Indian brother and sisters to space. So this docking mechanism multiple applications. Of course.
Or I think you lost that line there. Let me take that question across to Mahesh Murthy. Mahesh Murthy, we have, of course, 4 points which will automatically dock. But for that, the challenge for the scientists will be to bring the chaser 50 kilometers across, in fact, to within just 3 meters of the docking. In fact, Mr. Mahesh Murthy, please stay on with us. We have Mr. Nambi Narayanan joining us on the phone line. Mr. Nambi Narayanan, huge moment for ISRO where the docking technology will be demonstrated tonight.
Yeah, I think it's a very crucial as well as critical also, because only 3 nations in the world they have mastered this technology. But of course, the whole important point for us is that we club too many aims together very intelligently, so that you can not only save cost. For example, this docking itself, we are really using 2 satellites, which satellites are going to work later as satellites, but still we just try to send them as separate pieces, dock them together, then separate it again, and then use those pieces as satellites. So that way we are cost-saving consciousness. That way I have a feeling this is not only useful for Chandrayaan 4, but also it's useful for space station. And later, of course, it will be useful for Gaganyaan, which is more important. And you see, docking is a general requirement. You have to master that technology. So we are doing it. Hopefully, we will be succeeding.
Right. Thank you so much, Mr. Nambi Narayanan, for joining us and sharing with us your perspective on this very, very significant event. ISRO, of course, making us proud with multiple such missions that it has and milestones it has achieved in recent years. But let me take the question back to Mahesh Murthy. Mahesh Murthy, your thoughts on how India, as a spacefaring nation, and India, of course, has ambitious plans for the same. Can we succeed in future missions? And all of this, does it have some kind of, even a security dimension to it, given the fact that docking as a technology could have multiple implications?
Thank you. So I think one of the really interesting things to know is that it's high time we had this, and it's really a great moment for ISRO to do this. As you're probably well aware, the world's first docking happened 58 years ago, 58 years ago in 1966. It was a manual docking, like you said, that the Americans did. But 1 or 2 years later, the Russians docked automatically. So the Russians have been docking there for 57 years, and China docked in 2011 for the first time with Shenzhou. So we're here. So we're the fourth nation. It's taken a while. It's taken 2 generations, but it's high time. This is the time when, as we move past experiments to building permanent inhabitation in space, it's really important to not just send something up and down, but to send something up, hold it there, keep augmenting it. So if you ever want to build a space station, if you ever want to refill a space station, send people, to the space station, send supplies to another satellite, it's really important to dock. And it's really difficult. It's, imagine that 2 vehicles are trying to come alongside each other at the same time at running at about 28,000 kilometers an hour, right? Imagine doing that even at 28 kilometers an hour. Now imagine doing that at 28,000 kilometers an hour. That's what India is attempting. This technology has been held closely by the US, Russia, and China for, like I said, 59 years. It's good that we're getting it. It's an important step for us, even in the private space program, to be able to have these capabilities. It's a basic foundation step to be able to start building a spacefaring civilization. There are people talking about going to Mars, etc. At some point, we as a country will also have extraterrestrial ambitions. So it's a really important step from that point of view to be able to have this technology with us.
Right, and I think we have Mr. Mishra back with us now. Mr. Mishra, very significant over here that, for India, it's not just from the point of view of space exploration, but multiple other aspects also that this can have. And of course, with India's renewed focus on involving the private sector, how do you see? All right, let's listen in. I believe that the docking is about to happen. Let's listen in.
Orbit 2. During the non-visibility period, ground trace will be updated by extrapolation on the video wall. The non-visibility period is approximately for 3100 seconds. All the stations involved in operation shall continue in operations. Handing over to Mission Director.
This is Mission Director. PSLV-C60 SpaDeX Mission is accomplished with respect to SpaDeX A and B satellites. POEM operations will continue. Thank you.
The successful launch. In fact, the applause is there for our scientists for at least getting it right and putting those satellites where they belong. Now the next crucial 1.5 hours are very, very important. ISRO chairman there, you see Mr. Somanath congratulating his team as far as the successful launch is concerned. The next 1.5 hours are going to be a bit of a nail biter, because that's when we'll know, that's only when we will know whether the actual docking part of it has been successfully accomplished or not. Very, very significant, Mr. Mishra, in terms of the implications of what India is choosing to achieve today, because this is such an important aspect of space technology that only 3 other nations across the world have been able to achieve it.
Yes, space docking is not what you call is not that much easy to achieve, because as my friend Dr. Murthy has already said, that both the item they will be moving in a relative velocity. So almost all around 8 kilometers per second the speed will be, because there's an injection velocity, and they have to catch each other by using the proximity sensors, the laser range finders. So they have to sense each other. They have to come closer by using the onboard propulsion system, and they have to catch each other. So one will be the chaser, another one satellite will be like the front runner. So they have to come close to each other. They have to maintain so much accuracy to come and dock with each other or to attach with each other. The main significance of this project is especially human space flight program. When we are sending astronauts from space and they are going to dock or going to latch with the floating space station, where our astronauts will get
All right,
transferred.
let's cut across live to Mr. Somanath speaking, ISRO chairman.
15 minutes, the fourth stage of PSLV will change its orbit from 475 kilometer to 350 kilometer lower orbit by first phase of firing. And also the second phase of firing will be at about 1 hour 20 minutes later after the liftoff. So that process is continuing to enable POEM operations to happen. Further to that, the spacecraft is also going to wait for the solar panel deployment. So the team spacecraft is looking at whether the panels are deployed or not, so we'll get a confirmation soon. So as far as we are concerned, the mission is very well as far as the rocket is concerned, so it has placed the satellite in the right orbit. The SpaDeX 2 satellites are moved. You would have seen in the animation that they moved little one behind the other. So over the period of time, for the days, it will pick up further distance, travel to almost a 20-kilometer distance away. And then the rendezvous and docking process will start. And we hope that the docking process can happen in another 1 week. The nominal time is going to be approximately 7th of January. So I'm waiting for the panel deployment status. I think you have the status?
Yes, sir.
Yes. So I would like to say that the panels of the satellites have been deployed successfully. So congratulations to the entire team of the PSLV project who put the satellite in the right orbit. Also the SpaDeX team who worked a very innovative, novel, cost-effective docking demonstration mission using 2 small satellite bus architecture. So congratulations to them as well. And also two very important parties of this mission is the POEM-4, where we have 24 payloads hosted, which are from the startups, industries, academic institutions, research laboratories, and also from ISRO centers. All the R&D payloads are there waiting for testing in the coming days, in fact in months. So congratulations to them for successful accomplishment of all the mission objectives through the POEM. So once again, thank you. Before I hand over, I would like to request the mission director, Mr. Jayakumar, to speak a few words.
Thank you, sir. So hearty congrats to Team ISRO for venturing into the exciting domain of space docking. This mission is once again a POEM intensive mission. We have 24 payloads on board, and congratulations to the team who have developed these payloads adhering to our schedules. And congratulations to InSpace for facilitating the delivery of these payloads. This time we are flying the indigenous Vikram 3201 based mission management computer in POEM. Also we have interesting experiments like space robots doing debris capture and inchworm walking, then plasmaspheric and electron density measurements. 3 biological experiments are there, advanced inertial sensors, green propulsion systems, etc. And this month, in fact, we had 2 launches of PSLV from the same launch pad, that is the first launch pad. So after the first launch, the SDSC team, SHART team, was very quick in refurbishing the launch pad. Special thanks to them, and also to the teams in VSSC. We also had the movement of the fully integrated vehicle that is up to the PS4 stage from PIF to MST. So let me thank the SDSC and VSSC teams for making this possible. On this occasion, let me thank Chairman ISRO, who is a role model for all of us, and all the center directors for the ardent support provided, and to the mission executives, Sri Damodaran, Chandramouli, Grahadure, Raghavendra, and Surendran, who have worked as a coherent team. I thank all the SDS and SR agencies spread across different centers for their tremendous efforts to make this.
All right, what a moment indeed. A successful launch, Dr. Amitabh Ghosh, of this mission. But of course, all will depend on coming days, because the actual, mission of how this target and chaser will come together, they will first separate and then they will come together. And this is not going to happen over a few minutes or a few hours. It's a fairly long procedure that will last and extend up to several days.
Right. So as you heard the chairman say that it is going to happen on 7th January. So that's what I thought initially. I mean, I guess somebody said that it's going to happen in a few hours. No, it's going to take some time, and this is just normal. I mean, it sounds very tough, but it's like you have 2 vehicles. The relative velocity between them has to be such that they're almost equal and they have to be close to each other. So you can think of it like when 2 trains go very fast and then they're going at the same speed, then the relative velocity between them is the same. Then you can transfer things from one to the other. So it is of course in a 3D dimension to align this and connect things like the power supply. It's an intense thing. I don't know whether they are trying to connect the power supply though.
Yes, I think power supply is part of the program. There has to be a transfer of power for it to be a successful mission is what we understand. That is definitely part of it. But I just want to bring in Mr. Mishra to explain for us, because Mr. Mishra, sorry I had to interrupt you twice there because of the events taking place at Sriharikota. But can you explain to our viewers how exactly will this automatic docking system work? We understand that there are 4 points on the target and chaser which are supposed to automatically align once these two satellites come within a gap of 3 meters of each other, and that's going to take place on the 7th, as the ISRO chairman was saying.
Yes, actually both the satellites are launched at the same inclination, same plane. Here, all three things have to work in a very synchronized way. Like, what are the all three things? Mechanical, electronics, and onboard computer. They will be talking to each other, and they will be sensing how they are close to each other. And by using the onboard propulsion system, maneuvering has to happen. Then onboard sensors, they have to sense each other, as I mentioned, laser rangefinders, then proximeters. Of course, there are onboard cameras are there, multispectral cameras. They will look to each other, and they will come and they will sense, yes, this is the right time we can catch each other. Because if the moment, if there will be any slight mismatch in knowing each other, that then it may happen that they may miss each other or they may collide with each other. So it has to happen very precisely. That is the way how it happens when any what you call like astronauts, they go to the International Space Station. That's the way they go and connect with the space station, which is again revolving around Earth at the speed of 7.9 to 8 kilometers per second.
Right.
So that is the complexity of the system.
Right, right. And also, in fact, Mr. Mahesh Murthy, we are seeing a huge participation of in space of the various private sector organizations, which, India has now changed its entire space policy. Would you say that this is the first big success story when it comes to the private and the public partnership in space?
It's one of the many. I think the first Indian private satellite went up 6-7 years ago. It's been a while. So we've had satellites going up ever since. But it's now it's good to have not just ISRO launching our own satellites, because many Indian companies launch from SpaceX and other rockets as well. But it's good that ISRO is now launching our satellites, and also ISRO now can offer the capability of being able to dock two satellites, right? So this makes it easier, because otherwise what would happen is typically small satellites have a fixed life. They go up there and typically 3-4 years they're dead, they come down and they're brought back to the ground and they burn up in space. But now you have the ability to go send something for a longer period of time, not have it burn out quickly, add fuel, add supplies. You can send a large scientific mission. You can, send something up to repair it, send something up to fix it, send something up to replenish it. For example, if you remember, the Hubble Space Telescope went up, then something was sent up to repair it, and so on and so forth. So this brings an added capability that makes it much more robust, the private space program.
Absolutely.
It allows us to dream bigger and better.
Right. And Dr. Amitabh Ghosh, one of the important aspects of this is that, India has, of course, got its plans for a re-entry vehicle. We are, of course, having the Gaganyaan mission, the manned mission, as you rightly put it. With this particular technology as well, long term, actually having a lunar colony or another base in space, whether it's a space station, that becomes a very practical and a real possibility. And this is the first big building block to that, can we say?
So I think there are many technologies that have to fall in place. This is just one of them. And this is more relevant to the, if India was to have a space station, just like the US and the Chinese have a space station and the Russians used to have a space station. So it's more relevant to the space station where you have to align vehicles. For the lunar colony that you mentioned, that is a different game, and that's a more complicated game. You have to have habitats. You have to have space habitats, because the environment on the moon is very harsh. And that is what will eventually happen. So NASA plans to close down the International Space Station by the end of this decade. And they want to concentrate on making a base on the moon, as does Jeff Bezos' company, Blue Origins. But that requires much more work. You have to have in situ space, in situ resource utilization in space, means that you have to use space materials for survival in the space in a lunar colony. But yes, for an overall point, the overall trajectory.
Yes.
There are many technologies.
Dr. Ghosh, I'm sorry for interrupting you. We have the Minister of State in the Prime Minister's office, who's also, of course, in charge of the Department of Space. In that sense, Dr. Jitendra Singh is joining us. Dr. Jitendra Singh, a successful launch as far as the SpaDeX mission is concerned, a crucial step in India's own space exploration ambitions, because this docking technology will be a very fundamental part of India's plans for the future. Dr. Singh.
Absolutely, absolutely, Madhav. And taking off from where you said that Dr. Jitendra Singh also happens to be associated with the Department of Space, I think it's a huge, huge, huge privilege to be associated with the Department of Space at a time when ISRO, the team ISRO, is accomplishing global wonders one after the other. Now, as far as today's mission is concerned, this has heralded a new era. India today enters into an era of space docking technology, and that is something which gives it the opportunity to be a part of a select league of nations, being the fourth among the four nations who have actually sought to achieve this. And I think this is also something in keeping with the Prime Minister Narendra Modi's mantra of Atmanirbhar Bharat, because the mission is absolutely indigenously developed, and that's why it's been appropriately named as Bharatiya Docking System, the entire process which has been accomplished. And of course, this will pave the way for our future, the missions that have been lined up most ambitiously, the Gaganyaan, the first Indian human mission, and subsequently the Bharatiya Antariksh Station. And I think this also is a step towards the destination of Viksit Bharat, because the ISRO, I think this is something which goes unnoticed to many of our viewers as well. ISRO was born in the year 1969, and that was the year when, I mean, that's the year which has gone down in the history as the year when the first human being put his foot on the surface of moon, Neil Armstrong, through an American mission called Apollo the 8. Today, we have landed on the southern pole of moon before others, and now we are offering cues to others. Now, this is a mission which is going to gather inputs, findings for the other country nations as well. And not only that, we are also, if you look at the lined up missions for the near future, in 2025 March, we are going to have NISR, the NASA ISRO synthetic approacher, where the NASA is going to associate or collaborate with our agency, the ISRO, for a full Earth picture equipment. And as far as the SpaDeX is concerned, it's a very cost-effective indigenous mission. And I think the most fascinating part of it, the docking, which you might have heard in the English novels dedicated to the World War stories, where the docking was thought to happen.
Right.
Sometimes happened successfully, sometimes did not happen.
Yes, absolutely. And Dr. Singh, this is the most important part of what you were telling us, is that India today enters a league of the great spacefaring nations of the world, because this docking technology will be very, very crucial for our space station, for our manned missions also in the future, because the technology demonstrator of being able to actually dock and transfer power, that's the most basic requirement of a successful dock.
Absolutely. Not only that, once the docking technology has been mastered, can you hear me?
Yes, please go ahead.
Then it paves the way for transfer of operating payloads, which of course is the batteries, etc. Also the post-undocking, you can dock and you can undock, you can separate. You can transfer materials, powers, articles, payloads, also sometimes astronauts walking from one vehicle into the other. I think this is something which we are not even accomplished on in our road transport. You don't have two cars moving side by side on a road and then gradually coming together, opening their respective doors, and one passenger walking out from one car, stepping into the other one from. So that is something fascinating. So we have actually, as Prime Minister once said, sky is no limit. We've gone beyond the skies.
Absolutely. And congratulations to ISRO for this successful launch. And thank you so much for joining us, Dr. Singh, and explaining this to our viewers exactly what we can expect in coming days as well. A proud moment for all Indians indeed, as ISRO manages to blast off 460 kilometers, 470 kilometers into space with this particular mission as well. Let's take this back to our guests, in fact, with us. Mahesh Murthy, big question that would be on several of our viewers' minds. This is, of course, one big step, but space tourism, is that too ambitious, or are we counting our chickens before they hatch?
So, for space tourism, we need to have a human inhabitable spacecraft. We've sent smaller ones. I think these are steps. I mean, for space tourism, you actually, don't even need to go as far. I mean, space starts at about 100 kilometers above the Earth. These satellites are at 375 to 475 kilometers above the Earth. So, technically, you don't even need to go this far. But yes, certainly, there's a lot of people who want to go to space, who are willing to pay good money to go to space. Already, they started going on, Jeff Bezos' and Elon Musk's spacecraft to space. But these are certainly little steps. I think it takes each of these as a technology demonstrator says, yes, we've done this. I think these little upgrades, while, this evolution is needed for our own space program, where we are still, like we said, we've come here with the fourth country, it's great, but this, to be frank, this started 58 years ago.
Yes.
We're catching up with them, and it's better late than never. I mean, from now, hopefully things happen faster with a little more. I know we keep talking about how frugal and how cheap and how low cost our program is, but maybe that's holding us back. Maybe a little more injection of government funds will help this entire program go faster.
Okay, let me bring in Mr. Mishra on that. Mr. Mishra, of course, Mr. Murthy is saying that little more injection of government funds, much like the two satellites that are going to meet over the next 8 days. India also has a lot of metaphorical catching up to do with its Western counterparts and the other great spacefaring nations. Big plans, but ultimately it will be about achieving a lot more in terms of the various technology demonstrators. How soon before our space station actually can be launched, Mr. Mishra?
The space station actually is built in parts and parcels. It cannot be built as a single unit. So, of course, as I mentioned years back, 2018-19 timeline, this is the concept has been prepared to like the second step to the first human space flight program project, that is Gaganyaan project, followed by Gaganyaan project. In Gaganyaan project, there are 3 steps. One is first 2 is unmanned 1 and unmanned 2 mission. Third one will be manned mission. So followed by these 3 missions, or by accomplishing these 3 missions, subsequently there is a plan to have our Bharatiya Antariksha Station, what we are calling like International Space Station, built by India. It has to be built in modules. So all the modules has been launched in sequentially, like how the this Gaganyaan project is like a complete thing is called orbital vehicle. So it's a crew module, service module. Right. So in case of space station, it has to be a complete habitat. It has to revolve around Earth. It should not give us luxury like us currently has you are and myself having sitting at home, but it should have basic minimum necessity things
for the astronauts to survive. We'll have to leave it there, sir. Unfortunately, completely out of time. It's been a fascinating evening. ISRO making 1.5 billion Indians proud with every step and every achievement. Of course, the final and crucial success will be on the 7th of January, and we'll be waiting until that happens. Dr. Madhavdas Ghosh, Debrat Mishra, as well as Mahesh Murthy, thank you so much for joining us this evening.